In previous lessons, we've looked at templates both for functions and classes that worked with only one data type. In this lesson, I'm going to introduce you to function templates that work with two templated data types. So let's get started. What we want to do is define a max or maximum function that will work with, say, two different data types so that we could compare, say, an integer with a double. So to do that, we're going to start out just as we always do with template and then type name. We'll have T for our first type, then we have a comma, and then we'll call the second type U. That's just arbitrary, and typically because U follows T, you'll see that used a lot. We could have picked any name. Type 1, type 2, again, any name for the placeholder will work. So then, for the function's return type, we have to decide which type we want to use. So we're just going to pick T, and I'll explain why it's important, not so much the name, but that you're consistent in the return type. Followed by the function name, and then our parameters. So we'll have T arg1 and U arg2. For this function, we're going to use the conditional operator, which just is a quick way to write a simple if statement. And here's how the conditional operator works. First, you provide your relational expression. In this case, we want to see if arg1 is greater than arg2. Then the first part of the operator is the question mark. The question mark is followed by the value you want to return if the expression is true. So if arg1 is greater than arg2, we want this statement to return arg1. Then the second part of the operator is a colon. That represents our else part, and here we're going to write arg2. So the net result of this statement is that if arg1 is greater than arg2, it will return arg1. Otherwise, it's going to return arg2. And we get it to return by adding return keyword before the operator. And then we close off the function definition with a closing curly brace. All right, so let's test this. So we'll create a couple of numbers here. Let's do double first. We'll write double num1 is equal to 35.55. Then we'll write int num2 is equal to 13. Then we'll just call the function with num1 and num2. Let's add a little descriptor. X value is like that. And now let's build and run, then we'll explain a little bit about what's going on here. Alright, so the function returns the max value is 35.55. The reason I said you had to be careful about the return type of this function is that we have to make sure that the data that's being returned by the function will fit into the return type stated in the function definition. For example, if we returned a double into an int, then it might not work. So let's turn that around. Let's take num2, make it the first argument, then num1, build and run, and look what happened. Max value is 35. Well, clearly that happened because we tried to put a double value into an int return type, and the floating point part of the number was truncated. So that's why you have to be careful and make sure that you use your arguments correctly with the return type. Otherwise, you'll have a problem. Now, of course, we could have returned an int into that double without any problem. Put num2 as a larger int, leave num1 as a double. Now we'll build and run again. And you'll see that 130 works just fine. And that's because we're not losing any data going from the 130 into double. That's called a widening conversion, and that works without any problems. To review, we can create a generic function with multiple data types that are templated, if you want to use that term, by specifying the different placeholders in the bracketed part of the template statement. Then we just have to make sure we use them in the function correctly. And you have to pay special attention to the return type in certain circumstances, such as when we're mixing floating point numbers with integers, just because we have to worry about the possible loss of data if we try to put, for example, a floating point value into an integer data type. We've seen how to have multiple data types templated in a function. Now let's see how to do the same thing with classes. And that is going to come up in the next lesson.